forget to do this more often. Okay, looks like majority of people have answered. We got one person saying that they're special and the rest of the people saying that they're all ready to go. Perfect. So let's get started here with that. What are the roles of A, H, and K? So let us investigate the roles of these. So if we begin with the equation y equals x squared, so we know that's a quadratic equation, right? We know that's a quadratic function. And then what are the initial values of A, H, and K? Well, if we look at the function in between, in the middle here, you'll notice that when we want to get x squared, all of these values would be the following, or would have to be the following. A is 1, H is 0, and K is 0. Okay? So these are the initial values. These are the starting values of any basic function without any other things modified to it. So A, H, and K. I'll go over explaining what each letter represents, but don't worry. So what we're going to do with this is we're going to work with Desmos. And I'm going to do it myself because we can't really... because I feel like it's going to take a while with breakout rooms. So let's go through it. So for example, let's go through the role of A first, right? So for A, as the value of A increases greater than 1, what do we notice? So the equation that we're using is this here, y equals a x minus h squared plus k. So if we change the value of A, so we start with x squared, which is this function on the right here. Can someone give me a value greater than 1? Any number? Sure, 2 and 8 were the two I got. So 2x squared is in blue, and then 8x squared is in green. Okay. To show you that we're not really changing anything, I'll put it with brackets to make sure that you guys can see what's happening here. Whoopsies. So I've put the A values. What is happening to our graph? So red is the original, then blue and green are the changed ones. What's happening as we add a greater value of A? It gets more narrow, yeah. Right? You can say narrow or thinner, right? That's what happens, which means we can only assume if it gets more narrow as the number increases. If we pick a value less than 1, less than -1, for example, the proper assumption would be, oh, it must get wider, and not exactly. Okay? So if we put a value less than -1, so let's say we do -3 and -5, or we'll do like -100, for example, just to make a dramatic difference. What happens? Opens downwards, exactly, just very good. So opens downwards now. It's reflected. So the moment we stick into a negative number, yes, we still follow into the example of it gets thinner, right? Even if we use a bigger value of a number, right? But the fact that it's negative seems to flip it. And then the final case here, let's compare. Let's go back to 8x squared as our example, but then let's use a decimal, a number value between -1 and 1. So let's just do something like 0.25. What happens? So blue was when it's greater than 1. Green is where it's less than 1, but greater than 0. It gets wider. And usually the other word that some people use is fatter, but oftentimes we're not allowed to use that word at all anymore because of PC culture. You know what I mean? But yes, it gets wider. Okay. So the value of A seems to work with making it wider and thinner, essentially, right? And of course, it also works and figures out how we flip these functions as well. So now let's go to another value, like H. So H would be inside the bracket and it subtracts and adds, right? So let's plug in, for example, let's do x minus 5 squared. And we'll do a positive value in the other one, x plus 10. No, let's just do x plus 7 squared. All right. So red, once again, red is not changed. Red is our normal one. Blue is x minus 5 squared. And green is x plus 7 squared. What happens? Shifts to the left as well as shifts to the right, depending on the number, right? Yes, the x value definitely changes, right? We're shifting things completely over one way or another. Now, my question to you as a class is exactly, Lorraine saying depending on the sign. So what does that mean here?
Can I answer?
Yeah, go for it.
If, for example, x plus 5, it means the number is positive, and x plus 7 it means it's negative.
That is correct. Everyone hear that? So just to say that here, Lorraine is saying, just to reiterate what she's saying, in x minus 5, the number 5 is actually positive, and in x plus 7, the number 7 is actually negative. And you'll see that in green it shifted left, and in blue it shifted right. Okay? This is the tricky part, and Lorraine is absolutely right. When we look at this equation here, the negative sign is already present inside our formula. So if this was a formula, right, because the negative sign is there, if we plug in a positive value for h, which would mean shifting to the right, the whole function would stay negative inside the bracket. But if we plug in a negative number, two negatives make a positive, like x plus 7, and thus shifts to the left. So the final result does the opposite of what we expected to do. That's the tricky part here.
Confused. I am
Sorry,
confused.
Ren, you cut off just a little bit.
Sorry, I'm really confused.
Yeah, so we're gonna, don't worry. This whole point is an investigation, right? We're trying to figure things out. We're supposed to be confused. Don't worry.
Mister.
So let's figure this out here.
Mister.
A little more detail now. So as we increase the values of h, we notice, well, shifts to the right, and this one would shift.
Mister, you're just plotting out any numbers, right?
Yep, just any numbers. So just to kind of reiterate, like I could change this to 10, I can change this to 2. It's still going to work out the same way, right? So let's try to reiterate that in a little more detail. Essentially what I've done is this. Does that make sense? So notice how and why it reverses. When we plug in a positive number, it shifts to the right. But the end result is that we're just going to get x minus 5 in the bracket because of how we simplify. In the green, When we plug in a negative number into our equation, into our formula, right, it should shift left because we're plugging in a negative number. But when we simplify it mathematically, we get x plus 7. So that's why it reverses, like Stefan is typing in the chat right now, right? So it's weird. It's a little bit weird, and that's why it works out this way, right? Very, very odd. Okay. And so when the value of h is 0, we notice it doesn't move. It doesn't move. Okay. That's good. As long as you're starting to understand slowly. Yeah. That's why we take it one step at a time. We make you confused, and then we try to clarify your confusion. It works out better that way. Okay. So then let's continue on here. Now we are going into the role of k. So k is the final value, right, at the end of our function, right? I'm like pointing at my screen as if you can see exactly what I'm pointing at. I'm so stupid. All right. The k value there, right, is at the very end. It's not in the bracket. So essentially, I don't know. Someone give me a number. Any number. 4. Someone else give me a number. 5. Perfect. One more number.
7.
7. And we'll do that as a negative. We'll do the 7 as negative. This one's really easy. Okay. So once again, red is our original function. Blue, green, and black are the changed ones. You can see the equations on the left side. What do you think k does? If k is positive, so positive 4 and positive 5, the blue and green, what happens? So in comparison, moves up. Yeah, shifts upwards. Right? And so we can only assume if k is negative, then it moves down. Very simple. K is an easy one to understand. It's like the easiest one of the 3, right? If k is positive, moves up. If k is negative, moves down. Very simple, very easy to break down and understand. Yes. And Devon saying the technical term, to be more specific, absolutely. He DM'd it to me though, so you guys can't see it. It's called a vertical shift, right? So that's what Devon sent me. It's called a vertical shift, vertical meaning up and down. So the description of that transformation is called a vertical shift, and you can just say it shifts up or shifts down. So what you guys said is fine, but the actual term for it is correct to be called vertical shift. So obviously, if it's 0, it doesn't move. It's the same spot, right? So now, let's take a look at some of this all together. So then we can start having fun in writing functions like this. But why is it red? I don't want it in red. Give me like another color. Thank you. Okay. So I've now put multiple numbers inside, a, h, and k, and notice what happens here. Don't worry about the specifics of the points. What matters is what you'd see. Let's describe it. So first, let's talk about the first number, which is 3, the a value. We said for the a value, it should, when it's greater than 1, it should be thinner. When it's less than 1, a decimal, it should be fatter. In our case, or wider. In our case, the number is greater than 1. Is blue thinner than red? Yes. Perfect. It does exactly what we expect it to do. Okay, so it should be thinner. It is definitely thinner. The -5 is technically a positive, so it should shift to the right. That's what we said for the role of h. If h is positive, it shifts to the right. Did it shift to the right by 5? Absolutely. The vertex is 5, 2 when it started at 0, 0. So it did shift to the right by 2. And the last one is our k value, which is positive 2, which would mean a vertical shift up by 2, right? It moves up by 2, and looking at the vertexes, they absolutely moved up by 2. It started at 0, moved up to y equals 2. Okay? So all the numbers seem to work and make sense according to our answer here. And Lorraine, yes, we will get there though. That is
Excuse me.
absolutely right.
I have a question.
Okay.
Does the x value ever change?
Does the x value ever change? If we want to plug in and solve for a specific point, then you can plug it in and solve for it. Otherwise, when we just talk about the function, you just leave it as x. So only when we're specifically solving for something, we can plug in an x value, but otherwise, you leave it as x. Okay. So let's now try to figure out in a little more detail what these things exactly do. Okay. So we have a bunch of equations. We just need to figure out what the values are. So Lorraine also mentioned like HK is the vertex. And that is absolutely true. You'll notice that I wrote down the vertex here, and this is going to help us understand our values better as we plug it in. So let's make sure we all understand what's happening here. Okay. What is the value of A? In our first equation, what is the value of A? 3. Very simple. Right? What is the value of H? Everyone type in 2. I like it. Good. Value of K? 1. Which means we can get the vertex here. We have H, we have K, so we do 2, 1. That's our vertex. So having it in this form immediately gives us our vertex, 2, 1. And the next question to you is, how many x-intercepts do we have? We're sure writing 0, and 0 is correct. Okay? Think about where the vertex is. The A value tells you whether it's opening up or down. Since it's positive, it opens up from 2, 1, which means it will never hit 0. Right? It will never hit the x-axis. So as a result, no x-intercepts. Okay? We're going to leave the transformations for now. We'll get back to here. And we're going to leave the domain and range for now. We'll get back to there. Okay? We're going to get back to that. We're not going to touch that just yet. Because that's a whole, we're going to get to there. That's a long step ahead. Now let's work with the numbers first. So the second one here, I'm just going to go through 2 more with you. A is -2, H is 3, K is 3, which gives us the vertex, and it opens down, which means there should be 2 x-intercepts. Okay? So the A value being negative means it opens down and it's thinner, right? The H and K values tell us the vertex, and then that can help us figure out how many x-intercepts there are. And then we can continue onwards from there. I'll do one more, and the rest of it you can try. I'll give you some time to try it. So 1/2 is our A value here. Sorry, I scrolled a little too far down. H, since it's +1 in the bracket, should be -1 for the value of H. And for K, it's +5 on the outside, so that stays +5. And so we write our vertex, and we figure out, well, -1, +5 is still above the x-axis, and it opens up. So is that, how many x-intercepts are there? Visualize it in your head. -1, 5, and it opens up. 0, absolutely. 0 x-intercepts. Someone asks a question. I don't think there's x-intercept for the second equation. There absolutely is. So if we graph that, let me just graph that real quick. So the negative value of a means that it opens downwards. That's the important part. So for example, for the second one, so negative 2, x minus 3 squared plus 3, you'll notice we first indicate the vertex, which is 3, 3, and the negative at the front tells you that it opens down. So you draw the vertex and you kind of visualize it going down, and you'll see that it does have 2 x-intercepts there. Right? So it's not so much the value of a that matters, right? It's not that the value of a that matters, it's more so the sign that matters on opening up and down, right? The value of a specifically works with just whether or not it's thinner or wider. That's the difference. So little things that you start learning as you plug things in, which is good. So the next 4, I would like you to fill out the rest of the table. We have another question here, sorry. If the k value is 0, does that mean it has 1 x-intercept? Good point. And the answer to that is yes. If the k value itself is 0, you should have 1 x-intercept because the vertex is your x-intercept. That is correct. And you'll have an example of that here.
Mister, how would you
Yes.
determine if there's a number of x-intercepts again?
You got to like visualize it in your head. So first you find the vertex, right? And then kind of like graph that in your head. So you got to like visualize a graph, and you graph your vertex. And then you look at your value of a. If it's positive, it opens up. So from your vertex, you draw upwards. And then if it's negative, you draw downwards. And think about, does it touch the x-axis? And that's how you're going to figure out how many x-intercepts there are. Okay?
Okay, thank you.
No problem. So try giving it a shot. We'll give you 4. I don't think it should take too long. I'm going to give you all around 3 minutes. I think that's plenty of time. I think that's fair. So 3 minutes on the clock, and then we'll take it up. If you have questions, continue asking me in the chat. You have 30 seconds left to finish off, and then we'll take it up. All right, that is time. So let's write it all out one step at a time. So the A value here is 0.3. The H value is -2. K value being 15. So we get -2, 15 as our vertex. It opens up. It is below the x-axis, so there should be two x-intercepts. This one here, we have the A value is -2/3. The H value is +4. The K value is -8. Oh, sorry. I'm so stupid. Sorry, that should not be 2. That should be 0. Sorry. My fault. My fault. I read it the other way. This one here, the vertex is below the x-axis. Sorry. Below the x-axis because the y is negative. It opens downward. This should also be 0. No x-intercepts here. The next one here, the A value is 2. There is no H value. The K value is 9. So that'll be 0, 9, and it opens up, which means 0 x-intercepts. And the last one, -3, H value is -5, K value is 0, and this is the question that was asked earlier. If the K value is 0, does that mean it has one x-intercept? Absolutely. The vertex is your x-intercept. So it should just be 1. Any questions? All right. Looks like we're good. There are no questions that I'm getting in chat unless you're typing it out right now. Don't worry. If you're typing it out, finish typing it out. Okay. So let's summarize this and then go back to the chart real quick. Let's summarize each section. Okay. The role of A. Let's name it now. Let's give it the name. Okay. This is called a vertical stretch / compression. Okay. So the actual mathematical name for the role of A is a vertical stretch / compression. The reason why it's either or is because it depends on if you're making it wider or narrower. Okay. When it's more narrow, it's as if you're pulling, and thus it's called a stretch. If you're making it wider, it's like you're compressing it to make it wider, which is why it's called a compression. Okay. We'll go through the examples here once again. So the direction of opening, when A is positive, the parabola opens up. We understand that. And if A is negative, the parabola opens down. So those are the two concepts that we learned today. You already learned that last year as well, right? Understanding whether a parabola opens up or down. This should just be review, just looking at the very first value of your equation, right? Is it positive or negative? Then for the shape, right? If the A value is bigger than 1, regardless of negative or positive, it should be more narrow. right? If A is between 1 and 0, a decimal, then it's going to, oh, I need to circle this down. So it's going to be more narrow, not wider, and the opposite is true. This would be wider and not narrow. Okay? That's important here. So that's the summary of A. What helps a lot with determining, oh, does it get stretched? Does it get thinner? Does it get wider? Is ignore the sign, just look at the number. The number is all that matters. If the number is bigger than 1, right, just regardless of positive or negative, if the number is a bigger number than 1, it's narrower, it's thinner, it stretches. If the number is a decimal smaller than 1, it compresses, it gets wider. Okay? Then we talked about the role of H, right? If H is positive, then it moves to the right. If H is negative, then it moves to the left. And we call this a horizontal shift. Okay, so the mathematical term, horizontal shift. Shifting to the left, shifting to the right. And the vertex, how does it relate to the vertex? The H is the x coordinate of the vertex. So we can kind of we understand that, and we've kind of broken that down. Okay. Then let's go through the role of K. Devon said this earlier, which he was correct. It is the vertical shift is what K is. So if K is positive, it shifts up. If K is negative, it shifts down. Okay. And the value of K is the y coordinate of the vertex. And then now let's go through our x-intercept stuff. So this was what Angela was asking earlier, as well as some other students asking for, figuring out which one's which. So let's break down the rules. If K is 0, the graph has exactly 1, 0, or 1 x-intercept. Okay, maybe I should just use the text box so that the numbers are more clear. 1. If the K value is greater than 0, okay, so if it's above the x-axis and A is positive, it has 0. But if K is greater than 0, so if K is positive but A is negative, then there's 2. If K is negative and the graph is positive, there's 2. And then the last one, there's going to be 0. Okay. So those are the rules for the x-intercepts. Keep that in mind.
Sir,
Yes.
can you move a little bit upward?
Yes, I can zoom out for you. Absolutely. I'll try to fit the whole thing on the page here. There. Okay, So let's talk about our transformations now. How would we write it out? So first, I'm going to zoom in now. Hopefully you guys are done copying. Sorry, just going to zoom in so I can write a little better. Okay, so let's look at this example here. This is our example. We're going to go through all of the steps here. And I'm going to teach you how to write domain and range better. Okay? So, direction of opening. Opening up or down. We look at our A value. It's negative, so that's opening down. Done. Number 2, stretch or compression. The value is greater than 1, so this would be a stretch. Okay? Now the hard part. Okay? You need to write down all the transformations that are present inside this quadratic. So we're going to use all the words that we just learned. So for the A value, like we said before, the A value is a vertical stretch or compression. We have specified that it is a stretch. So the way you write that out, it is a vertical stretch by a factor of 2. Just like that. Notice how I do not include the negative. The only thing that the negative tells us is that if it's opening up or down. And I'll show you how to write that. The one you write right after that is vertical reflection. Okay? This is indicating that it's opening down. So I'll write that kind of beside it here. So if it opens down, it's been reflected down. Our next one, we can now go to horizontal shift. So horizontal shift to the right, because H is positive, by 3 units. I need more space. Maybe I can do this. There we go. Okay. So vertical stretch by factor of 2, vertical reflection, horizontal shift right by 3 units, and the last one, vertical shift. Why is it in red all of a sudden? What has happened? Vertical shift by factor, not by factor. Vertical shift up by 5 units. So those would be all the transformations present in this function. It's a lot. There's a reason why I said this is going to be a little more difficult and confusing, right? So we want to break it down one step at a time, understanding what are all these transformations. And the only way you're going to get them is identifying those numbers. What is A? What is H? What is K? Once you can identify all of those, the transformations are just translating that into English words. Okay. Coordinates of the vertex would be 3, 5. K is positive, this is negative, so there are 2 x-intercepts. Okay. And the last part, the hard part. Okay. Domain and range. I need to teach you all how to do this. Okay. Some of you may have learned this last year in grade 10. If you were in the academic course, you may have learned how to write domain and range. Some of you did not learn. So I want to make sure that we're all on the same page. We're going to assume that no one has learned it. And we're going to start from here. So the domain, the definition of the domain, like we learned last week on Friday, was that the domain is all the possible values of x. When you think of a quadratic equation, is there a restriction on that x value? No, x can be anything, right? The parabola looks like this. It can go anywhere. Well, in this case, it would be downwards, right? But it keeps going on both sides and it keeps going on forever. So there is no restriction on the x value. So the way we write the domain is something very, very unique. I'm going to write it in black so it's a little more obvious. We use a squiggly bracket. Okay? We say x, and then we write this weird e, and then r. Okay? Now, some of you might be going, what the hell is that? That's a fair question. When I want to read this out, in math, there are certain symbols that mean certain things, right? We already know that, like the equal signs means equals, plus means add, minus means subtract. It's the same idea, but the domain and range is a little bit unique because it creates like a sentence, right? So when we say that x is an element of real numbers, this is always included. Same thing goes for y and the range, actually. So the domain and range start the same way. X and y are the element of real numbers. What that tells us, right, is that x is any number from negative infinity to infinity. That's all it's saying. So you don't have to know the intricacies. I'm not asking you to remember the intricacies. Just remember, I should start my domain and range like this, because this tells me that it could be any number, right? The parabola goes on forever. It could be any number. The only thing different in the range is that we add on a little bit. We draw a vertical line. Have you noticed that when you type in on your keyboard, you can actually type vertical lines like this? This is not I or L. They are completely different. They're actual vertical lines. There's a reason for that, and that's for this. So this thing here, right, it separates. And then we look at the k value. The k value is 5, right? So y, and it opens down. So if it opens down, we say less than or equals to 5. Let's talk about what this means. Because once again, the whole thing here is I have no idea what you're talking about, Mr. Choi. This is completely new to me. You need to go in detail. Sure, we can do that. Same thing. Element of real numbers. And this section here is the restriction. When we are to graph this out, okay, let me try to graph this out here. Let me zoom out so you guys can see it. So let's try to graph this here by opening up another page, bringing it to the right. So when we graph this out, okay, so here's our graph. Okay. X can be any real number. If I continue to zoom out forever, X is going to keep going on forever. It just keeps going on and on and on and on and on. There's no point, there's no restriction. X goes on forever. Okay. But for y has a maximum point. So for the y value, the range is restricted. There is a point on which the y value cannot go any higher or any lower depending on opening up or down. If it opens down, it has a maximum point. The highest value that y can be is 5, which is the k value of the vertex. That's right here. The reason why it's less than or equal to is because it's opening down. The y value has to be less than or equal to 5. And that's our range restriction here, right? The highest point that it can be is 5. And that's going to be true for this one here. When we talk about the range and we are to write it in a full sentence here, we're saying the range is y is an element of real numbers such that y is less than or equal to 5. That's essentially what that black written out is. We've created an actual full sentence using symbols. What if y is 0? Good question. We can actually go through some of these examples, and that's exactly why I left it for last. That's a very good question, Lorraine. So let's use what we learned here just now and answer the same chart we did earlier. Okay? So first, want to make sure everyone should have copied this down by now. Use it as a guideline. The whole point of my notes and the whole point of notes when you do homework is to use the notes. Don't go to your homework or don't go solving questions without the notes. What's the point? All right, just keep that in mind when you solve questions. A lot of students misunderstand, like, oh, once I learn it, I should try it on my own. I should try to figure it out. No, the whole point, have the notes beside you, do the homework problems, and if you have questions, look back at the notes and solve. It's like an open book homework problem. That's how you're supposed to do homework, right? You're not just supposed to do it off memory. That's not the point. If you do it enough, it then turns into memory. Okay? Wise advice from Mr. Choi. All right. So let's go back to the other one here. So this was the chart we started off at, right? So let's talk about our transformations here. Okay. Sorry, it's going to have to be a little small. I'll zoom in a bit. So we have our A, H, K values here. I want to zoom in enough. Okay. So looking at it, our A value is positive. That's a vertical stretch. Sorry, the number is greater than 1. It's a vertical stretch by factor of 3. So we just copy that down. Done. There is no horizontal, there is no vertical reflection. It's a positive number, so it opens up. We don't need to write anything for that. Then we say horizontal shift by right by 2, because H is positive, and then vertical shift up by 1. So those would be the 3 transformations for our first one here, just looking at our A, H, and K values. Now let's look at the domain and range. So the domain and range, once again, the domain is easy. As you've noticed by now, there is no restriction for the x values for a quadratic equation. Specifically for a quadratic equation, there is no restriction on the x. So the domain is simple. Start it off with xer, and that's it. You end it. No restriction. The range is the one you need to worry about. So you started off the same, YER, such that there is a restriction. We think, why? Does it open up or down? This one opens up. The equation opened up. It's a positive A value. So since it opens up, we write greater or equal to. And then copy down the K value, 1. And that will be your range. Okay? So greater than or equal to if it opens up, less than or equal to if it opens down, and the restriction is going to be your K value. Right? So I'll write it down here. Opens up. And then this is our K value. So the opposite would be true. If it's less than, it would be less than or equal. Oh, opens down is less than or equal to. So we'll do one more here. Okay. So same thing here. This would be a vertical stretch because the value is value of A is greater than 1 by factor of 2. This would be a horizontal shift right by 3, and then vertical shift up by 3. And I do need to add one more, sorry, which is a vertical reflection. And I kind of have to stick that in there like this. Really weird way of doing it, but yes, there it is. So vertical stretch, vertical reflection because it's opening down, horizontal shift to the right by 3, vertical shift up by 3. Now domain and range. Domain stays the same. There is no restriction on X for a quadratic. The range, there is a restriction. This time it opened down. So it's less than or equal to, and then the K value. And I think now at this point is when people go, oh, usually this is usually the point where that happens. So hopefully that's true for you. You can try the next few on your own. Okay. Try the next few on your own. I'll give you 5 minutes to complete all the transformations here, and then we'll take it up. Okay. If you have questions, just DM me. I'll message you back. But try giving it a shot. Use the notes on the next page, like on this page, to help you. There's the whole point of this is to help you. Okay. So 5 minutes, and we'll take it up. The timer's glitching out. I'm just going to close the timer for now. Okay, most of you should be finishing up now. So let's take up these ones one by one. Okay. So I'm just going to quickly do the vertical reflection. Whoa. So I'm going to stick these where they are going to go already. So because we already know where they're going to go. You should have the vertical reflections on these two for sure. Okay. And then we'll do the rest. So this one here, you should have said vertical compression by factor of 1/2. Because the number is smaller than 1, it's a decimal smaller than 1, so it should be 1/2. Horizontal shift left by 1, and a vertical shift up by 5. Okay? So those are our transformations there. And we're going to write out the domain and range here. The domain, once again, doesn't change. XER. Hopefully you guys have realized that. The range, YER, such that Y, which way does it open? Opens up, so it's greater than or equal to the K value, which is 5. And there we have it. Your domain and range. Next one. Okay. Vertical compression, again, it is a decimal smaller than 1 by factor of 0.3. Okay. Horizontal shift left by 2. And then vertical shift up by 15. Okay. So just that's all the transformations. Those are the values written out in words. And we write the domain and range. So the domain XER and the range YER such that y is once again greater than or equal to, because it's a positive a value, 15, which is our k value. Okay. Our next one. Now, at this point, some of you are probably going, Mr. Choi, it's a pain to write out vertical compression, vertical stretch, horizontal shift, vertical shift. Like, writing that out multiple times in a row is painful and annoying and redundant. Like, I don't like it. Fair. Short form it then. So here, just shorten it, just like I did now. So vertical compression, vert comp. Okay. Horizontal shift. Can't really say shift any shorter. You can't really kind of go shh. Write out shift at least. And then vert shift up. Down by 8. Okay. So there's our transformations there. Domain and range. XER. Range. YER. Such that y is less than or equal to -8. And there we have it. The last two, we're almost there. We're almost there. Bear with me here. Okay. Vertical stretch by factor of 2. There is no horizontal shift for this one. It was 0. So we just go straight to vertical shift by 9. Up by 9. There's no reason to write horizontal shift. There was none. Then you write your domain and range. XER and the range YER such that positive, so it's y is greater than or equal to 9. And there's our range. Our last one here. Okay. Vertical stretch by factor of 3. Horizontal shift left by 5. There is no vertical shift for this one. Okay. So there was no vertical shift for this one. Let me see if I can write this a little bigger. Maybe space it out a little more. So that's easier to read. There we go. Okay. And then domain and range, we write that out. Domain XER range YER such that opening down y is less than or equal to 0. The k value is still 0, you write 0. And that should answer, I believe, Lorraine's question. What if y is 0? So hopefully that answers your question there. So even if it's 0, you write it down in the range. It has to be there. Okay. Are there any questions about this? Going once. Going twice.
Sold.
Sold. Exactly. All right. So what we're going to do, okay, we're going to end it there. I don't think I should start the next lesson, or else we're going to be kind of rushing it a little too much. So I'm going to end it there. Okay. We'll continue on tomorrow with 1.5. So I'm going to edit the Google Classroom thing, and I'll move 1.5 to tomorrow with 1.6, because I believe we're supposed to do that tomorrow. Please note, so big announcements. I'm going to end, hold on. Let me